Today I will discuss about Galactic Swarm Optimization. So this is a very easy optimization algorithm which mimics the gravitational pull that exists in between galaxies, subgalaxies, solar systems and planets. So what actually happens is you know suppose our planet Earth, this Earth is located into where? This Earth is located into solar system. It rotates around the sun along with other 8 planets. So Earth is located under solar system. Now this solar system is again located under the Milky Way galaxy, correct? And Milky Way galaxy is located under this Milky Way galaxy was located under a super galaxy known as Virgo supercluster. Virgo supercluster. Now Virgo supercluster is again located under another super galaxy, and so on. And there are millions of super galaxies, under which millions of sub galaxies are there. Under the sub galaxies there are millions of galaxies, and under the galaxies there are billions of solar systems, and under the solar system there are many planets that exist, but all are rotating among each other or by centering some sun-like what I would say stars due to the gravitational pull, because sun is pulling Earth, and this not only Earth, it is pulling Mars, it is pulling Mercury, it is pulling Jupiter and all other planets. And the sun is being pulled by Milky Way galaxy, right? This is a spiral galaxy, big spiral galaxy, and it is the second largest spiral galaxy that exists in the observable universe. Actually, we assume that there is one non-observable that we cannot, or until now no telescope has been able to observe that part of universe. That part of universe is defined as non-observable universe, and which the telescope has already observed. Any type of telescope, be the first one invented by Galileo Galilei, be the most advanced one, any type of telescope, if it has observed that part of universe, it comes under the observable universe. Now all these Earth, Sun, Milky Way, Virgo, then we have something as Landraker, all these are observable, part of observable universe. Now I have already said that they are all aligned with each other due to the gravitational pull. Now what happened is, this optimization algorithm, yes, this can be referred as nature based, but not bio-inspired, because here, as you can see, there is nothing biology here. So it is nature based, right? Because it is the nature which is creating all these pools and all this alignment and all these things. So what it assumes is, it assumes that, say, the entire feasible region of optimization problem, or the solution space from where we can expect to find the most optimal solution, can be compared with or can be analogous to super galaxy. Correct? Super galaxy. Now, what happened? Within this super galaxy, we create at random basis some subpopulation or population, I would say. Population of probable solution P. We refer it as P. Right? So they are analogous to galaxy. So solution space, you see, this is your solution space, correct? So this is analogous to super galaxy. And under that, these are the population that was created randomly. Say, these are the subset of the super galaxy that are created, or population of probable solution created under the solution space. Now, under this solution space, there are again some subpopulations are created. They are known as subpopulation of probable solution. Right? But this subpopulation of probable solution is better than the population of probable solution, but exists within this population of probable solution. So they are analogous to solar system. And the optimal solution with respect to the population of or the subpopulation of probable solution is known as the planet, like our Earth. Okay. Now what happens is, we can identify the planets of all the subpopulation, from which, say, this is our most optimal solution for this population or subpopulation, or the optimal solution. This is the set. As I said, first is the solution space, then come your population of probable solution, then if I enlarge this part, then come your probable of subpopulation of probable solution, and within that there will be some most optimal solutions. Correct? Most optimal solution can be found from the subpopulation. Now if I compare this most optimal solution, this most optimal solution, this most optimal solution, this most optimal solution, where I compare with each other, this solution with this solution with this solution with this solution, then you will find the best solution, or the planet, right? Best solution of this part of subpopulation. But this best solution of the best planet, you can find it here also for this subpopulation, here also for this subpopulation, and here also for this subpopulation. Right? So for each subpopulation, I will get an optimal solution or a planet, optimal planet. Okay? And for If I compare those planets with each other, then I will get the best solution of the population. And as there are randomly many population within a solution space, and if I compare all that optimal solution of those populations, then I can find the best solution among the entire solution space. This is a very confusing concept, but very, very easy concept. Let us repeat it. Suppose this is our solution space.